Today I'm going to talk about my capstone project for Comp 4911. It is for an anonymous and secure web form for an LGBT-based nonprofit designed to secure sensitive and personal information. And my name is Radwan Ahmed. So what the nonprofit needed, they wanted an intake form, which is a web form where people can share their personal experiences. It needed to be have privacy by default, since people are sharing their stories. This meant that this should respect their privacy, meaning that it should secure data, not store any IPs or cookies, or share the data to third party as well. And ultimately, it's supposed to be a safe base to be heard, so people can speak freely and openly without fear of their data being compromised. For the development methodology, I chose an agile, iterative approach over waterfall, and this is to be for 12 to 13 week timeline from March 20th to mid-June. So the waterfall method was first looked into, which is sequential in nature, which happens in phases. This results in a development process that's more resistant to change, especially in later phases. And the next development process that was looked into was the iterative approach. This is more, this differs from the sequential as it's cyclical in nature, where development processes happens in incremental cycles before launch, and each cycle completes the full process. So each cycle results in the plan, design, test, and review as a loop. So you can incorporate client feedback. Each cycle allows for client feedback, and ultimately this would result in a project that's more aligned with the client, especially with needs that are evolving. And the iterative approach development process works well with the agile framework, which which embraces working software over documentation, customer collaboration, and responding to change. Prefers responding to change over rigid planning. So for the requirements, this is a set of functional and non-functional requirements for the MVP. And the MVP, well, the initial requirement started off as a list from the client, and then this is further evolved through further research into security and best practices for maintaining privacy and securing data, such as PIPEDA, which is a federal law for securing and managing data and privacy for users. And while this law is mainly for private companies and nonprofits are exempt, it was still used as a guideline. So users should be able to fill and submit a form anonymously. Privacy policy should be shown. Administrators should be able to securely log in and view submissions. They should be able to read entries and delete them as well. And IP addresses should not be logged. No fingerprinting or cookies implemented. Data should be transmitted over HTTPS, TLS. Submitted data should be encrypted at rest on the hard disk. No data should be transmitted to third parties, and maintainable with someone with limited coding knowledge, as well as input sanitization to prevent injection attacks. Five options were explored. Each option was weighed against the must-have requirements and feasibility within the timeline, and each option had a major requirement that it had failed. So for the build from scratch approach, it would use Next.js and React and a cloud database and Docker. This would be very technical to maintain, especially when I needed to include a no-code user interface. This would be unfeasible in 13 weeks. So I looked at another solution, which is Baserow. It had a no-code user interface and encryption as well, but is ultimately a database tool, and it would be hard for non-technical administrators to be able to manage and filter through the submissions and responses. CryptPad was another solution to explore. It offers end-to-end encryption, but deletion is not full, as it only compacts the history. And to fully erase form submissions, you need to create a new form, which is unfeasible since this meant changing the form URL, and there had to be a better solution. I looked into Nextcloud as well, and this offered encryption such as in transit, such as TLS, but it is a full productivity suite, meaning there's a lot of unnecessary overhead. It includes a lot of different services which are not needed, such as a calendar and file management. So this would result in a higher compute cost, and this would be too inefficient for our needs. And Formbricks was looked into. It's an open source survey platform which is lightweight, using Next.js and Postgres as the backend. It has a no-code user interface, and you can self-host it. And this was ultimately the chosen solution. And this shows the traceability matrix of why Formbricks satisfies each of the must-haves. So it satisfies anonymous submission, privacy policy, secure admin login. Data responses are readable. You can delete responses. IPs aren't logged. It uses HTTPS, TLS for encrypted data in transit. Data is encrypted at rest at the server, Google Cloud virtual machine. Input is sanitized to prevent injection attacks, and minimum coding. There is no coding required, since everything like the form, all the form functions are accessible through a no-code graphical user interface. In terms of the system design, this is a 3-tier monolithic architecture. Formbricks is the main monolith. It is a bulk of the code base. Not only does it render the UI, but it also serves the API for updating the database through submissions and deleting all submissions as well. And the project is logically separated into 3 tiers. The first tier is a proxy tier. It sits at the edge. It's handled by Traefik, and it listens on port 443 and port 80. It handles redirection, so plain HTTP requests are redirected to HTTPS, which is encrypted. And the second tier is application tier, which is Formbricks, and it handles authentication for the admin, rendering the form, submissions handling, such as creating submission and deleting submissions, and editing forms, and all through its internal API. And the third tier, which is the data tier, handled by PostgreSQL, handles form submissions, and it stores form submissions and admin credentials. And these are this database is encrypted at rest on the Google Cloud virtual machine disk. And as a note, only the proxy is internet facing, So only ports 80 and 443 are exposed, and every other port through the internal, all the internal services ports are closed and unreachable with the web. For the system design, encryption scheme, data is encrypted in transit using TLS and encrypted at rest using AES 256. This is an overview of the handshake process of how the user's browser and the server creates a secure encrypted tunnel. First, the user's browser offers their encryption scheme. The server picks a scheme and presents its certificate of authenticity. The browser verifies whether it's legit, and then they share keys, and then afterwards an encrypted channel is established, and then form submissions are now secure over the internet, and data secured at rest using AES 256, and this is provided by default with Google Cloud Console. So, provisioning the host. So when installing the Google Cloud virtual machine and setting it up, as a note, this runs the whole stack on a single server, which is an E2 small configuration. E2 small comes with 2 gigabytes of RAM, and I also included swap memory for an extra 2 gigabytes in case the 2 gigabyte minimum requirements aren't enough, and this would help with load spikes. The disk was chosen to be 30 gigabytes, which is plenty, and Debian 12 as the Linux operating system of the virtual machine. For the network configuration, I changed it from a dynamic public IP to a static external IP. This would allow the address to never change, which is crucial for the DNS. It provides a free domain, and this needs to map to a static IP of the server. And running this 24/7 would cost roughly $30 a month. And this is a rough overview of the steps of how to install everything onto the virtual machine. Starts off with installing Docker. Docker is a containerization platform where you're able to install everything into a container, which is able to be run on different platforms, agnostic of the specific hardware. And Docker makes it really much more easy to deploy as well. So Docker needed to be installed from the official repository, as well as installation files for Formbricks and generating the secret keys. This is all configured. Formbricks is configured into Docker as well as the reverse proxy then had to be installed. And then this is configured manually and wired into the Docker config files as well. And finally, this is launched. This is all deployed together with Docker Compose. And Formbricks does offer a one-click. It offers an automated script to install everything, but I wanted to understand how everything works under the hood, especially how the proxy in Formbricks is installed and configured. And inspecting the setup script allowed me to understand how to manually configure the reverse proxy myself, so that I can fully understand how it works. And for testing, I chose a black box testing approach, which verifies the behavior without expecting the internals. And I made sure that each must-have requirement should trace to at least one test. So for testing how it performs, I tested to see if you're able to submit a form and check if it's anonymous. The form submission is anonymous. I wanted to check whether Users can submit without consenting to the privacy policy, whether they can create an admin account, log in and view submissions, permanently delete a submission, and perform all form operations with the user interface only. And these were all successful. And this is a overview of the submissions. As you can see, everything is logged as an anonymous user and a unique response ID. And responses can be individually viewed and deleted as well. And you can create a survey as well from a template or from scratch. And the next testing approach is to see if whether it's secure. Wanted to see which ports were exposed to the internet, ensuring only the proxy is exposed to the internet. Making sure that you cannot make any non-encrypted connection requests to the form, and to ensure that an updated encryption scheme is used. And the minimum enforced is TLS 1.2, and making sure that no access logs would store any identifying information such as IPs. And these were all successful. And here in the implementation, I added more detailed information about the implementation, as well as a testing strategy. As you can see, Docker Compose PS is this script, when run on the cloud terminal, would show which ports are exposed. Only port 80 and port 443 were exposed, which is tied to the proxy. And trying to connect to the internal ports through the VM IP directly resulted in a connection timeout. And as a guide for the administrator, day-to-day operations were stored in a GitHub README. Which covers managing the form and creating a form, as well as managing the server as well, such as starting and stopping the instance and checking the billing details. And ultimately, what was handed to the client was a GitHub repo with the README, how-to video, and the form itself. And as a final reflection, this is ultimately shipped to people, real people, where I was able to get firsthand feedback on the project with users. And the biggest lesson was the hustle, finding a client, maintaining the relationship, and managing the hurdles throughout the entire process. So this form went out and was live during the Pride Parade, and people were eager to share their experiences. This resulted in a stronger client bond, where the client was really pleased and were willing to even offer paid work. And the impact was seen as well. People's reactions and hearing their stories firsthand, as well as their appreciation for this and the attention to privacy and security, and their satisfaction made me really satisfied. So thanks for listening to my final presentation on my capstone on a secure and private and anonymous web form.